Okay, so for example 9, we're asked to find the accelerations and the tensions in these connected systems. But as I said just now, it's a connected system. So we know that these two will have the same tension and the same acceleration. So should be fine with that, right? Okay, so first we start by looking at mass 1 and like writing the equation for it, right? So here we can see that in mass 1 we're going to choose that this way is the positive direction. That's because this is the way that it's falling down towards this way. That's what I'm choosing anyway, that M2. That's probably going to mean that M2 is heavier then, but yeah, it's falling on towards this way, so this is going to be the positive direction, like that. So knowing that, that's very important to note. And then we have a tension force here, and that's going towards the positive direction, and we have a weight force here. But the weight force, it will be in the weight force prime direction, right? A component of the weight force. So that would look like this, right? We can see the tension, and then we can see the weight force with the component of the incline, right? Sine of theta, and that's this part right there, right? And then we just equal that to mass times acceleration for M1. And now to look at M2, similar situation, is except that the T, oh hold on, sorry, the T, right, is going to be in the positive, in the negative direction now, and the M2G is going to be in the positive direction, right? As you can see here, that's what's shown right there, right? And then once you have to add these together, you combine them, and then the T's cancel out, the tension force cancels out, and you end up with this right over here, over right there. And then you simply solve for A. After you solve for A, you should end up with something like this, right? So that should be for both of the masses. And then after you have the A, you can plug in the A with the T, and then you can plug in the A with one of these, right? One of these equations in the system of equations, and you should get something like this. Should get something similar to this right here, right? And that would be the tension force. Okay, and that's about it for that question.